Here in example 3, if we plug in infinity, so let's think about what natural log looks like. So if we plug in infinity to the natural log, it is going to infinity. And then if we take the cubed root of infinity, we get infinity. So here we have this indeterminate form, and we can use L'Hopital's rule. So we do limit of the derivative of the top, which would be 1 over x, and derivative of the bottom. Now this is x to the 1/3, so the derivative would be 1/3 x to the negative 2/3. And then if we simplify this down before we find the answer, so we're going to have 1 over x, and this is 1/3, and then we've got x to the 2/3 on the bottom. And if we multiply by the reciprocal, we would get 3x to the 2/3 on top over x. And then if I plug in infinity now, I still get infinity divided by infinity. But I could reduce it. So try to do as much algebra as you can before you try to use L'Hopital again. So this is 2/3. Down here, this has an exponent of 1, which is 3/3. So if I reduce my x's, then I get 3 over x to the 1/3 if you subtract them. And now if I plug in infinity, I get 3 divided by infinity, which is 0. So the answer is 0. On example 4, think about your unit circle. And so we've got 1, 0. So the tangent at 0 is 0 divided by 1, so 0. So I end up having 0 minus 0 over 0. So we get that indeterminate form of 0 divided by 0. So that means we can use L'Hopital. So let's do limit of the derivatives. So derivative of tangent is secant squared. Derivative of negative x is negative 1. Derivative of x cubed is 3x squared. And then if we plug in 0 now, so secant of 0, so we look at the cosine, and we get 1. So we have 1 squared, which is 1, minus 1, over 3 times 0. So here we get 0 over 0 again. So that means we can use L'Hopital again. We have that indeterminate form. So now we're going to do derivative of this numerator and denominator. So we've got limit as x approaches 0. So the derivative of secant squared, remember secant squared is secant all squared. So it's a chain rule. So we're going to bring the 2 in front and take 1 away. So it'd be 2 secant to the first. And then you do derivative of the inside, the secant, which is secant tangent. Then we have derivative of negative 1, which is 0. And then we have derivative of the bottom, which would be 6x. And if I plug in 0 now, I have secant at 1, so look at the cosine, is 1. Tangent at 0 is 0, so I have 2 times 1 times 1 times 0 over 6 times 0. So I have that 0 over 0 again, which is indeterminate form. Now, that means I can use L'Hopital again because I have the 0 over 0. However, let's try to simplify this as much as we can. So if I plug in my zeros here, so the limit as x approaches 0 would be 2 times 1 times 1, but let's leave tangent alone, and let's leave the bottom alone. So that would be the same as saying the limit approaching 0 of this is the same as saying 2 tangent x over 6x. Now I'm still getting 0 over 0, which means L'Hopital, but now it's a lot easier to do L'Hopital with that instead of this triple product that we have up here. So now we're going to use L'Hopital because we have indeterminate forms, so we do derivative of the two tangents, so the coefficient stays in front. Derivative of tangent is secant squared. And then we've got derivative of the bottom is 6. And then now we're going to plug in 0. So remember, secant of 0 is 1. So we get 2 times 1, which is 2 over 6. So the answer is 1/3. And then example 5, we've got pi to the left. So if we look at sine at pi, so let's look at our unit circle. So sine at pi is 0. So we put 0 up there. And then 1 minus cosine at pi is -1. So we plug in -1. We get 0 over 2, which is 0. So L'Hopital wasn't even needed. We can get an answer. So just because L'Hopital might be used doesn't mean that it always is used. You're only going to use it if you have indeterminate form, which would be 0 divided by 0 or infinity divided by infinity. And here we have 0 divided by 2, so we can actually get an answer of 0 without doing any more work.